Hi students, in the previous lecture you have studied the centripetal force and relation with radius. That is, the F is inversely proportional to the 1 upon r square. Today we are going to see that why the every object is directed towards the center of the earth. Every object attract toward the earth, that is, the earth attracts every object near it towards itself because of the gravitational force. That is, due to the gravitational force every object attract towards the it. But the center of mass of the earth is situated at the center of mass of the earth is situated at the center, so the gravitational force on any object due to the earth is always directed towards the center of the earth. It is the reason, and you have to study. And there is the second point is very important. Today we are going to see that is earth gravitational acceleration. What is the, that is the acceleration. Acceleration means the change in velocity. Change in velocity is called acceleration. But here the change in velocity due to the gravitational force, that is the gravitational acceleration. Suppose if we throw any ball, any stone above the earth, at that time when it goes upward direction, its velocity changes, and one time that its velocity becomes the zero, and then it will come back towards the earth, and again its velocity started to increase, and that is the highest velocity when it fall on the earth. That is the change in velocity at every second is called acceleration. That is due to the gravitational force. So it is, look here, Earth's gravitational acceleration. The gravitational force due to the earth on a body results in its acceleration. Is called acceleration due to the gravity. That is the G. We have to denote that G. That is the notation. That value of G, we have to find the value of G. G means the gravity. Let an object of the mass m situated at a distance from the center of the earth. Let F, that is the formula, F equal to G capital M divided by R square. But F equal to mg, that is the formula of weight. Here F same, so RHS must be equal, that is the mg equal to Gmm by R square. M get cancelled, therefore G equal to Gm by R square. Suppose that object is on the surface, so R equal to capital, that is the radius of the earth, and that is the put here, therefore G equal to Gm by capital R square. It is the formula for the finding the gravity G. That is the gravity, acceleration due to gravity. That is the R equal to R, G equal to 6.67, that is the universal constant, 6 into 6.67 into 10 raised to minus 11 Newton meter square per kg square. M equal to 6 into, M is the mass of the earth, 6 into 10 raised to 24, and R equal to 6.4, that is radius of the earth. R equal to 6.4 into 10 raised to 6. Put those values in this equation. We will get 6.67 into 10 raised to minus 11 into 6 into 10 raised to 24 divided by 6.4 into 10 raised to 6 bracket square. 6.67 into 6 is 40.02, and that is the square of 6.4 is 40.96 into 10 raised to 6 square means 10 raised to 12. 6 into 2, 12. Therefore 10 raised to 12 get cancelled. We will get remain only here 10. Therefore 40.02 into 10 divided by 40.96. Therefore its multiplication will get 400.20 divided by 40.96, and that is the division is 9.77 meter per second square. It is the gravity, that is the value of G, that is the value of G. But the acceleration acceleration due to gravity depends up only mass and the radius of the earth. It is the important point. Mass and the radius of the earth. It does not depend on the properties of the object. Which type of the object it does not depend. That is only depend on the mass and the radius of the earth. Here also you know that is the there is a formula. There are the two objects. If one object becomes twice, then force also becomes the twice. But distance between them become twice, then the force becomes the 1/4 times of the 1/4 times. That is the point you have studied, and you must prepare this. Next, that value of G is 9.977 is generally, but it is same all the places, is or not? No, it is different at different places. That is, we have to see that the change along the surface of the earth. That is, you know that the earth is not perfectly spherical, but it is flatter and at the poles, and it is the bulk at the equator. So the flatter means the radius is small, and bulk means the radius is great, and the distance low, distance small means attraction great. Like this. Look here. That is the value of G is not the same everywhere on the earth, because the earth is not exactly spherical. It is the first point. That is the second point. Earth is flatter at the poles, so the radius of the earth is smallest. That is, the radius of the earth is the smallest, and the radius small, the attraction is large. Radius small, attraction is large. G equal to 9.8832 meter per second. But earth is bulbs at the equator, so the radius of the earth is greater or larger, so the attraction is decreases, and it becomes the 9.78 meter per second. That is the difference between on the poles and the equator. So the G is not same on the everywhere on the earth. That is the point. There the value of G is not same everywhere on the earth. If we go the height above the earth, change with height. If we go above the earth, as we go above the earth surface, the value of R increases. The value of R in equation F equal gm by R square increases, and the value of G decreases. Value of R, because that is in equation R is square. The value of R increases, the square becomes the bigger value or the bigger number, and if we divide by the bigger number, then answer will get smaller, so the G decreases as we go above the earth. So understand, you have to understand, you must understand that R increases, square increases, and if we divide by the bigger number, that is the G always increases. That is next point, that is change with the depth. If we go inside the earth, that is the value of R also goes decreasing. That up to the towards the center, value of R goes to decreasing. The part of the earth contributes the gravitational force. The part of the earth contributes the earth's gravitational force felt by the object also decreases. That is the mass. As we go towards the center, that the mass will go decreases, and so that is the effect of the R and M, that the Gm by R square is the G is the decreases. It is also these are the 3 points. These are the 3 points we have studied. On the surface, on the change with the height, and change with the depth. That is the 3 points. Today we are going to see the difference between the mass and the weight. That is the mass. What is the mass? Look here. That is the mass is the amount of matter present in object. amount of matter present in the object, that the weight is the force with which the earth attracts object, W equal to Fmg. SI unit is kg. Here SI unit is Newton, capital N. That is, it is scalar quantity, means it is scalar quantity, means it has no direction. It is no necessary direction to understand. That is scalar quantity. But it is vector quantity because it has the gravitational force act on the mass. So direction must be important. So it is the vector quantity. The value of mass does not change place to place on the planet, on other planet. If you take any object on the another planet, then it does not change its mass, but the weight changes the place to place on other planet or on other planet. Means if we take any object on the other planet, it will change. If you like this video, then like and subscribe it, and send to your friends. Take care, stay home, study all very happily. Thank you. Good day.